Pi. It's such an elusive number. 3.14159265. I never really understood what it meant when I was first learning about it. I mean, it pops up in so many equations about circles, like the circumference and area equations. But why? Why does pi work? Why is it 3.14159.265? So pi is defined as the ratio between the circumference and the diameter. Right here I have a circle of radius, right now it's 1.5, and I have the circumference divided by the diameter shown. So if I increase the radius or if I decrease it, the ratio is always 3.14. Now there are other decimals, but the computer doesn't calculate past 2 decimals. But what the point is that it doesn't matter how big the radius is. In all circles, the ratio between the circumference and the diameter is 3.14, and that's how we get pi. It's a universal constant that describes something about every single circle. Now, let's try and understand the equations of a circle beginning with circumference. By now, we've already established that pi is the circumference divided by the diameter. But really, the diameter is just 2 radii put together, or just 2 times the radius. Substituting the diameter for 2 times the radius, we get this equation, the circumference divided by 2r. Now, all we have to do is just simple algebra. To eliminate the 2r denominator, we can multiply the 2r by both sides, which cancels it out. So now, we're left with the equation for circumference of a circle, 2 times pi times r. Easy, right? But the area of a circle, however, is a little bit more complicated. Here I have a circle divided into triangle sectors with one half red and one half blue. By now we've established that the circumference is equal to 2 times pi times r. So the circumference of just half of the circle, or the circumference of either the blue or the red semicircles, is just pi times r. This will be important later. So now let's go back to the circle. Bear with me, but I'm going to separate these sectors like this. Now if we put them together like this, we get this shape. And now this kind of sort of resembles a rectangle whose area is given by length times width. If we were to just pretend that this shape was a rectangle, the length would just be the circumference of just one of the semicircles that we established, right? And the width would just be the radius of the circle. Now imagine what would happen if we took our original circle and divided it into even more triangle sectors, and more and more, until it's essentially basically a rectangle. So much so that we can treat it as a rectangle. As we established before, the length is pi r and the width is just r. So because we've basically made this circle a rectangle, we can plug the length and the width of our area into a rectangle equation and get the area of a circle equals pi r squared. I hope now you have a better understanding of pi and its uses.